Hi everyone, my name is Dmitry. I'm a software engineer and Python and C++ mentor. This is the third video in a series that I'm making that is called Saving Expired Software with Explicit State Management. In this video, we're going to talk about Python software, different types and scales of Python projects, and which ones of them do need deliberate design, which ones of them do not necessarily need it, and which are less clear and where we as software engineers tend to make mistakes in choosing whether to exercise caution and whether to actually deliberately design our projects. So without further ado, let's jump straight into it. So I'm going to divide Python projects into three rough categories, three rough bins, let's say. So it's going to be type 1, 2, and 3. Note that they are very rough. The boundaries are not well defined. And so that is intentional. It's just a mental model, like for reference. It's really not meant to capture everything precisely. So the type 1 Python projects are small scale Python projects that don't really need deliberate designing efforts. It's basically the projects that you can read entirely in like 10 or 20, up to 20 minutes or 30 minutes, like some little amount of time that you can fully understand and internalize. And at that point, you'll be able to work with them regardless of kind of what kind of design they're implementing. Well, most of the time. I'm not talking about reading machining instructions. But if we're talking about Python, then if you want something small and something deliberate, then you can just write it this way. And even though it's not gonna have any sort of, design to it, it's not gonna hinder the usability of that thing. So the examples I came up with here is the Lagrange function that I talked about previously, or this random Python script that I wrote that basically walks a directory and finds all the PDF files and puts them into a zip directory on the output. Like I just basically hard code what I filter for and so on. It's just like some inner loops and stuff, and none of that actually bad in this case because it's really simple. Yeah, and that basically concludes the idea of type 1 projects. They never need a design. Now, on the other end of the scale here are the large scale Python projects. Those projects tend to be developed by big industrial teams of like tens of engineers or maybe hundreds of engineers, and for that reason, it can be anything from like moderate online retail sites that have to keep track of your shopping carts and have to interact with like financial services and like with warehouses and so on and so forth, to giants like, I don't know, YouTube or Reddit or anything like that. And those applications are special in the sense that they cannot exist without a deliberate and very precisely managed design, because it's just incomprehensible for so many people to interact with each other and kind of push the project in all directions without a grand plan, grand schema of things that kind of defines where the project needs to evolve. So there's no really choice about whether we should be spending our time deliberately designing those projects or not. There's just no choice here. Only one option is to actually do it. Otherwise, it's just not going to work. And then there are type 2 projects. This is again a rough category, and the idea here is that it's basically not big enough that it's incomprehensible to develop it without a deliberate software design, but it doesn't fall into that category of like small projects that can be just read in one shot and understood in one shot. So those this middle ground is kind of uh it's this is where we really have to uh d- decide precisely whether we want to spend our time like coming up with a deliberate design, or and how much time we should actually spend doing that, or we should just kind of try to write them as is and it's fine. The choice depends on a lot of factors. So some of the factors, the first thing to consider is like the immediate scale. So what I mean by immediate scale here is it's this idea that, well, when you decide that you want to create some software project, you have an idea of what it's going to look like by the time you finish developing until it's like usable for the first time. And that's the immediate scale. That's like what you're aiming for right now. It may be you as a software engineer or you as a team. Yeah. Then the next concept is the expected eventual scale. And that is basically everything that happens after you've developed the initial version of this. Because it's the two situations, in one where you write something that you know will only be used a couple of times or like some number of times, but is not going to change a lot, or you have no reason to believe it's going to be changed at all, is very much different to a situation where you're writing something that is maybe sort of a proof of a concept, but at the same time, you know that this thing is going to take on much more responsibility and function later on. And so, if you're writing the second thing, you like this is very relevant for your decision of whether you should and how much of your time you should spend coming up with a deliberate software design. So the third thing that comes to mind is certainly the performance requirements. Obviously, even if this system is kind of small and you realize that it's not going to take a lot of coding to do, if you have very strict performance requirements, it still forces you to think a lot about its design, because random development is not necessarily gonna verifiably lead you to a place where your performance is gonna meet the criteria. So in many cases, if you have strict performance requirements, you're kind of forced to spend a lot of time designing this thing until you can, or like as long as, and you have to do it to a level, to the extent that it allows you to kind of prove that it's going to meet those performance requirements. So next thing is kind of in the same vein, which is the reliability requirements. Again, if your system has to be available all the time, or your system has to be extremely reliable in terms of the outputs that it produces, you have to deliberately design for that. You cannot just expect the system to exist in that always valid state. And yeah, because there are so many factors that that can affect this, be it people and other software engineers contributing to the project, or you yourself contributing to the project, because every change is kind of a risk in terms of it, like it being able to break things. Also, you always, when you run your thing, it runs on something, so that something can misbehave, can turn off, can crash, and so on. So if you want to protect against all of that, you have to consider designing your system very deliberately to meet the reliability requirements. And obviously, the list doesn't end there, and there's a countless number of various reasons why you might have to consider that problem, and why you might have to design your software deliberately. Some examples are like necessary audit trail or constrained resources, and all of those things go into the decision making of whether you should spend your time deliberately designing your software. Um, yeah, so the takeaway here is the choice that we need to make here is hard, it's multidimensional, it requires deep thought and expertise, vast context about the system, how it's going to be used, its scope, and so on. And since the choice is so hard, it's kind of obvious that a lot of in a lot of cases, it's very easy to get it wrong. And that is something that we want to kind of protect against and we want to improve. So one additional thing, one like that makes this problem even further, that exacerbates the issue, is the human factor in this. Because imagine a software engineer that gets a task assigned, or like a bigger, so it's not big, but bigger project assigned to them, where they need to implement this system that seemingly falls into the type 2 category, where basically they're pushed, or they desire to complete it as quickly as they can, and they start assessing its complexity, they start thinking through the plan of how they're going to go about implementing it. And yeah, after some consideration, they decided that this new project X lands somewhere here in the unclear scale. So yeah, to give you some context about the scale, on the left we have the type 1 projects that certainly do not need any designing. On the I'm sorry, my headphones disconnected. On the right, you have type 3 projects where you have things like YouTube and Reddit that certainly need a design. And then in the middle, you have the unclear part. So here, the unclear part, and your project kind of lands here. The thing is that we as software engineers, when we think about those projects, and even if we're in the case when we are able to kind of think through the entire plan of implementing the thing, we're kind of it's kind of tempting to just go ahead, start doing it, see how it goes, and also just try to implement it according to the plan that you came up with as quickly as you can, so that you obviously deliver it as quickly as possible. You kind of push forward the overall projects, the business, and all of that is very much valued by the business. So that is very enticing for people to pursue. The problem is that this human factor in that equation, in a lot of cases, pushes out proper thought and proper consideration for whether the project needs this the level of attention that it really deserves. And one particular problem is that it might very well happen that 3 months later, that same project has grown. It kind of drifted toward right, and it is probably now it's entirely in this probably needed design section, a part of the unclear section, um, which means that it should really it means that this project that doesn't mean that this project cannot work. So it still functions, it still is like performing the function that it's intended to, but it it just means that maintaining that project is much more expensive than it should actually be, because now, like, if we started here and there was no deliberate design in the first place, we just wrote something, then it drifted to the right, which means that we've expanded it, added some new functionality without deliberate effort to reduce complexity. Now it's quite complex, quite close to like actually falling apart without a design, and it doesn't have that deliberate design, which means that it's extremely tough to work with at this point. And in practice, I've seen way too many such type 2 projects that don't have a deliberate design, but that are very well into that section of probably needed. So the problem here, let's kind of summarize the problems here. The problem is that projects quietly scale up to levels unsustainable without a deliberate design. Uh, and but they never actually get that deliberate design, because the friction that is introduced by the lack of that deliberate design is kind of invisible. It's just like, yeah, it took that developer X number of hours to implement that feature, which is kind of hard to judge whether that's quick or not, and it's also affected by a lot of other factors. So it's very hard to conclude that certain deficiency of your team is caused by this particular project being very tough and hard to work with. And the second problem is that, well, in response to the first one, I could say that, oh yeah, we should just, design more and spend more time designing our projects. But that's not really an option, or like business optimal option, because it's just too expensive to just randomly decide to spend more time designing projects. Like, it's not a solution to the problem, it's just complaining. So what should we actually do about them then? Well, I think the first thing we should really do is be aware of that pitfall, be aware of the human factors, and be aware of all the factors, actual factors, that should go into making that decision about whether you want to design your thing or not. And second of all, we should try to develop techniques or frameworks that help us design our software at a lesser cost, just to drive this cost of designing things a little bit, to find some middle ground solutions that don't necessarily introduce a full-blown, very much looked after design, but still introduce enough structure and enough clarity into the source code of the project that it remains maintainable throughout its lifetime. So actually, that is what I'm gonna be talking about in the next video. There's a certain technique, a certain approach that I've developed in my years of software engineering career that I like to take for those type 2 projects. And I think it can be applied in a lot of domains, in a lot of spaces, in a lot of contexts, and it kind of allows you to come up with a good design quickly and provide some very tangible benefits to your software development. I'm very excited to share it. I hope you are too. So stay tuned, and I'll see you in the next one.